We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Dear student, in steel structural design, lessening battering system topic are there. So in previous video session, we discuss about lessening, its functioning and design procedure as per the IS 800-2007. In this video session, we'll discuss about battering, its functioning and design procedure of battering as per the IS 800. So first we start, what is battering? So the lessening and battering both are provided to resist transverse shear force occurs when the column is defect. So compression member can also be built up in intermediate horizontal connecting plate or angle connecting 2 or more elements of column. These horizontal connecting plate are called battens. So the number of batten shall be provided such that the member is divided into not less than 3 bay within its actual length of column. So these are the use or battering application. You can see that batten should be provided horizontally of truss to resist the covering of roofing covering materials. Also in provided steel roof truss as a horizontal member to resist transverse force. In aesthetic point of view, also it should be provided in the wooden dome in a architectural point of view. So the design requirement for battering are given in IS 800 clause number 7.6 page number 51. So the number of batten shall be such that member is divided into not less than 3 bays. It means you should provide minimum 2 or 3 battens throughout the length of column. Batten shall be designed to resist simulation of VB and M. VB is nothing but longitudinal shear and M is moment. So we should provide the batten in horizontal. So there are the shear force occur as VB and load into distance. It create moment at the end of batten. So we can design to resist longitudinal shear as well as moment. So our first step, the number of batten should be decided into this way that minimum not less than 3 bay occur and batten shall be designed to resist this simulation of shear force and moment. So in third step, before we start third step, slenderness ratio, first we know that longitudinal shear and moment. How it's calculated? So longitudinal shear VB is calculated is equal to Vt into C divided by Ns and moment is denoted by M is calculated Vt into C divided by 2N. Vt is nothing but transverse shear force and C is distance between center to center of batten longitudinally. N means number of parallel plane of batten, usually 2 we have taken. S is minimum transverse distance between centroid of bolt, rivet group or welding. S, you can see that figure, this is the S, minimum distance between centroid of 2 bolt, rivet or you can say welding in group. So third step, slenderness ratio is given in clause number 7.7.1.4. So here for battering system we can use effective slenderness ratio. So the effective slenderness ratio KL upon R E of batten of column shall be taken as 1.1 times KL upon R O. O means original or usually we can use KL upon R normal lambda. So the maximum actual slenderness ratio of column to account for shear deformation effect. So to avoid the shear deformation effect, we can take effective slenderness ratio KL upon RE, and it should be 1.1 times the original slenderness ratio. Next step, spacing of batten is denoted by C. Clause number 7.7.3. For any component of column, there are the two criteria to finding out C. First one is C upon R minimum not greater than 50. Second one, C upon R minimum not greater than 0.7 times KL upon R for built up column. Here you have to note down, if you have to find out built up column, so KL upon R should be calculated about ZZ axis, because it's the major axis of that built up column. And these two criteria of C, whichever is smaller, take as a C of smaller value of these two caudal provision. Next, thickness of batten is denoted by T and given in clause number 7.7.2.3. T greater than LB upon 50. So T should be greater than LB upon 50, where LB is nothing but distance between innermost connecting line of bolt perpendicular to the main member. Then after deciding the thickness of batten, next step should be effective depth of batten is denoted by D and given to you clause number 7.7.2.3. So it depends on types of batten. So for intermediate batten, D greater than 3 by 4 times A. For end batten, D greater than A. And for any batten, D greater than 2B. So D is distance between outermost bolt in a longitudinally, and A is distance between centroid of main member, and B is width of one member that should be provided for battening. Then after finding out the effective depth, we calculate overall depth of batten and is denoted by capital D. How can find out overall depth? So overall depth D is equal to DE plus 2 times end distance. Both the end distance you have to calculate, and summation of D, it creates the overall depth of batten. Next, we find out transverse shear force VT. So is given to you clause number 7.7.2.1. VT is equal to 2.5% of factor axial load of column. The same transverse shear we have to calculate in lessening. Over there, same equation we can use for battening. And the last step is overlap is given in clause number 7.7.4.1. So for welded connection, if you provide the battening through welding, so at that time overlap shall be not less than 4 times the thickness of batten. Same criteria we have to taken in lessening if we providing the welding. So in that battening case, the same criteria should be taken for overlapping. It should be not less than 4 times thickness of batten, and it should be noted that the batten of column have least resistance of shear component of column with lacing. So here you can also note it down, batten column have least resistance to shear compared to column with lacing. So generally we provide the lessening system compared to batten, but at that time when you provide the horizontal member also only, then you have to compulsory design for battening system to resist the transverse shear force. So these are the 7 to 8 step you can provide or design procedure for as per the IS 800 caudal provision recommended. So this 8 step finally you can design for the battening, and it's designed for resisting the transverse shear force. Thank you.